Alright, so today we're going to be doing day 3, and we're going to be talking about inscribed angles. An inscribed angle is an angle that has its vertex on the circle, and its sides are contained in chords. So this is different than a central angle, and I'm going to remind you of what that is. A central angle was an angle that had a vertex in the center, and the sides were radii. And so what I want you to decide real quick is, of the 3 pictures here, what are they? Are they inscribed or are they central? One and 2 are inscribed, and 3 is central. So we're going to talk about some rules for how inscribed and central angles work together. And so I'm actually going to go straight to 3 so we can talk about it real fast. Yesterday we learned that if angle 3, for example, was 80 degrees, that the arc that angle 3 cut was also 80 degrees. So what we're going to focus on today is if this is angle 4, and I'll go ahead and name this arc AB, if angle 3 is equal to 80 degrees, and arc AB is 80 degrees, what we're going to learn today is that angle 4 is equal to 40 degrees. And so that's our rule. The measure of an inscribed angle is equal to half the measure of its intercepted arc. So we can do this kind of 2 ways. If I tell you that angle 1 is 35 degrees, then you could tell me that arc 1 is 70 degrees. If I tell you that arc 2 is 240 degrees, then you would tell me that angle 2 is 120 degrees. So we're focusing on the interplay between an inscribed angle and the arc that it intercepts. So what I want you to do right now is, let's look at example 1, and we're going to find x and y. And so what we're going to do is we're going to process through this step by step. Angle x is made up of the letters P, T, and Q. But the arc that angle x intercepts is PQ. And so because angle x intercepts a 40-degree arc, angle x is equal to 20 degrees. Yesterday we also talked about the whole segment addition and arc addition idea. And so when we're trying to find y, well, there's no angle that intercepts y. There is no QTR angle. So there's no help there for us. So then we have to go to the next angle, which is angle S. So PSR intercepts the big arc, PQR. And so if angle PSR is 50, then arc PQR is 100. So by knowing that PQR is 100 and knowing that PQ is 40, we can find the measure of QR, which is equal to 60. So therefore, y is equal to 60. There are 3 other rules that come into play to help us, and they're all things that you already know. We've already talked about them all. It's just that the circle gives us something different to work with. You guys have seen this picture before. Because these angles are vertical, And if these angles are, if these two triangles are congruent, which they are, it also means these two angles are congruent. Now, as far as a circle goes, the reason why this happens is because if I were to name these angle 1 and angle 2, well, angle 1 intercepts this arc that I've shaded there. And angle 2 also intercepts the arc that's been shaded. And so the rule is, if two angles intercept the same arc, then those angles are congruent. So because angle 1 and 2 both intercept this shaded arc, angle 1 is congruent to angle 2. For this circle, we're going to draw a diameter. Now, hopefully you remember from what we discussed yesterday that when you draw a diameter, you break a circle into a semicircle, which means that the top is 180 and that the bottom is 180. And so what happens when we draw an angle to a semicircle is the same rule that we just discussed. Since this angle is cutting the circle in half, and as we talked about, any inscribed angle is half of the arc that it cuts, any angle that gets inscribed into a semicircle is a right angle. And that should make sense because we have 180 degrees in this arc, and the inscribed angle is supposed to be half. The third extra rule is that if a quadrilateral is inscribed in a circle, and inscribed simply means inside, then opposite angles are supplementary. And this should be common sense. So if I were to draw quadrilateral here, and it can be any shape, the idea is that at this point right here is a diameter. And so that any two angles that would go opposite of each other would be equal to 180 degrees. We've seen this in trapezoids, and we saw it in parallelograms. And so, you know, any two opposite angles are going to be supplementary. So like, for example, if this is 85, then this angle is 95. If this angle is 70, then this angle is 110. All right. So what I want you to do is I want you to pause the video and I want you to attempt these four pictures using the rules that we've discussed leading up to these examples. Please pause the video, try them all, and then once I unpause it and you unpause it, we'll go over all of the answers together and I'll walk you through step by step. Alright, so hopefully at this point you've taken the time to try to figure some things out, okay? But I'm going to go ahead and talk about each one individually, and we're going to try to go through this process. Now, for this problem right here, where I started is that ADB is 40 degrees. So this arc is 80 degrees. And since this is a diameter, this arc is 100. Then I went to angle DCA. This angle is 30, so this arc is 60. And so this arc is 120. And so now at this point, I have enough information to get angle X, Y, and Z. Since arc AB is 80 degrees and angle ACB is X, X is 40 degrees. Since DC is 120 and angle DBC is Y, Y is 60 degrees. Since angle BC is 100 and Z is angle BAC, Z is 50. one was a lot easier. X is the arc that's intercepted by this angle, and so I double it. X is 40. Y is the angle that intercepts 110 degrees, so Y is 55. This bottom left one's a little bit more complicated, but not much. We know this is a right angle right here. We also know that this arc is 40 because of the 20-degree angle right here. And so what ends up happening is this would be 140. And so what ends up happening is this is 20 degrees because angle X intercepts arc 40. And so then, because this big triangle, this angle is 70, which means that this is a right angle and that this is 20. And so since this is 20, what we have here are 4 similar triangles if I were to connect this. And so since we have 4 similar triangles, this arc is also 140, which makes Y 70. So we just put together all of our rules that we talked about yesterday to help us out with that one. With this last one here, since this arc is 80, this arc is 100, and then because of our chord rules, since this chord is congruent to this arc is also 100, and this arc is also 80. And so now we can do this really quick. X is 40, Y is 50. So again, the key is 180 degrees drives everything with this, whether it be straight lines, triangles, semicircles, whatever. And then you do either half or double depending on what you have. If you have the arc, you half it to find the angle. If you have the angle, you double it to find the arc. Let's talk about 2 more rules about how things work, or just one really. The measure of an angle that's formed by a tangent and a chord is equal to half the measure of the intercepted arc. So I kept all the half things together. So for example, if this arc right here is 260 degrees, well, we know there's 360 degrees in a circle, so this arc is 100. Well, if this arc is 100, this angle is 50. Not only do you know how to split 260 down to 130, but now, hopefully you see that now we have a supplementary pair, a linear pair, and that's where this information came from. If a linear pair is split to a circle tangent, then the 2 angles together are supplementary. The 2 arcs together will equal 360. So in our final example here, we know this arc is 140. This angle intercepts this arc, which makes this arc 120. Since there are 360 degrees in a circle, we also know that this arc is 100. And so now we can find X and Y. All we have to do is take half. Y is 50, X is 60. We could keep going. This angle intercepts 140, so it's 70. This angle intercepts 100, so it's 50. Let's check ourselves. These 3 angles equal 180. These 3 angles equal 180. So hopefully you guys are like, mind blown that like now we understand where the straight line idea comes from and where the triangle principles come from. Has to do with the intercepted arcs of a circle. Alright, so in the workbook, it should be page, and hold on one second. Okay, so we're on page 319, and what I want you to complete is 1 through 16. So you're going all the way to the back for 1 through 16. And then we will check these as soon as I get in class tomorrow. Good luck. If you have any questions, I'll leave a key for Mr. Wilson.